Hi guys, today we have binarysearch.com weekly contest 42, which is of course a very special number. It will start very soon, in under 1 minute, so earlier today we had ad coder contest which turned out to be very nice and pleasant, both in terms of problems and in terms of the results. So let's see how this one goes. Tomorrow we won't have any contest, but I have some other ideas for the videos, so stay tuned for tomorrow as well. Yeah, so now we're just waiting for the contest, and I would like to say a couple of quick words about this amazing platform. As you can see on the right-hand side of my screen, there is a chat, and you can talk with other people. You can communicate. Of course, you can't communicate during the contest, but in practice you can, and it's really helpful. And also, during the contest, we'll see the status here. It's a bit unusual, but it's fine. The contest will start shortly. We're supposed to refresh the page, I believe, to get the problems. I don't care, to be honest. Okay, except that we just generated all the values, so we are very lazy. Okay. I think it's fine. Yeah, it's fine. Hash map store every change. from whoever is before case finish case endpoint but after k minus first starting point. I'm not sure. Let's see. We guarantee that everything is different. We are not. That's not great. That's not great. I want start to be after k minus first start. And I want end to be before case end. Actually, I have no idea whether this is the expected solution, because else we want to count 0. It's not ends, it's end. Oh, we are not supposed to. Okay, okay. Oh. We are supposed to return indices, so we want to filter, I believe. Filter by lambda that takes in requests and returns this condition. I have no idea whether it's correct or not. Int object is not subscriptable because should be done like this. I have no idea. Yeah, see, that's not correct. Like here, we think that this user can be. Is K? He can't, he clearly can't. Why do we count him though? Like his request is a 1-1. Starts are all sorted. So want his start to be at least second. It's true. Or is it because it's like 0 indexed, we want it to be like this? But then what? No, it's not the supposed way, because what does it mean to have k plus first element? I don't think it works actually. It sounds very fishy. Yeah, see? Obviously, second user can't be. Am I supposed to trick it like this? Actually, that was better. You see, I don't want to sing, but maybe I need to. Okay, my idea is the following. Like, this is the latest time at which user could have attended the site. It has to be at least start k. Because if it's at least start k, actually, honestly, I think it should be at least start k minus 1. Because then it's able to. But then what it means if k is 0? No, it should be at least k's. And at most k's? I don't understand. It's not supposed to work, to be honest. This is very strange. Okay, whatever. Fixed light itinerary. Oh, that's a famous problem. What do we have to do though? Two-dimensional list of uppercase alphabet edges. But there was misspelled. First, becomes valid. Okay. Oh, whoa, 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 whoa. Whoa. It's hard. I mean, how are you supposed to deal with this? What if there are too many airports? Like, you obviously can't go for greedy. Because if you try to fix like current for the best that you can, you may end up with something that does not maximize like over the entire pass. You see, a list of flights may contain some different flights that we don't have like no idea what to do with them. Yeah, okay, whatever. Do people actually solve it already? Okay, somebody already solved it. Okay. I don't understand. Like, what do we want to do? If you try to match first airport, it may become like suboptimal further, right? This constraint suggests some dynamic programming on M, but length of the itinerary length of the edges. Okay. We can. Okay. Right. So, This is not correct, but I don't know. I don't know. I don't know. I mean, we'll overwrite it anyways shortly. Okay. Also n minus 1, I think. It's kind of strange. I want n to be on the outside, to be honest. Okay. I would like to see that what is like the current, what is the cost to change to that place, right? So we can do like this. What do we want? What do we want? We want from this minus first to this J0. We want from I to ternary. Wait, edges are bidirectional or not? No, only one directional. Okay, cool. So now we computed like what is the cost of transforming current edge into any edge, right? We can now think what happens when we transform like first edge to all possible edges. Actually, this is like the cost to transform. This should be different, I think. It should not be to J, but it should be a dictionary. Yes. I think I know what I'm doing. Oh, come on. Not having a tab is very annoying. This is our starting distances, and we say like, hey, you know what? This is the city at which we are currently at, right? So this is the key. Key is the city. And this is, and this is like how many characters we changed. Now, here we have a city. Then we try it like this. We can't change the current city. And dp at I. Like current must be the key of something in edges. Edges should be dictionary. Edges should be dictionary. Edges should be graph. I'm writing terribly, I just want to type it as fast as possible. Now edge is a graph. You want to process every city that can be reached gets the distance of a minus 1. Actual lambda, and this is dist. Oh, this. Plus distance from, no, plus this distance. Like, what is the cost to change this? What is the cost to change this to out? Yeah, I want to obviously maintain minimum such cost. And therefore, there is a slight issue though, like, okay. That object does not suppose, man. Jam, so what? So what do you want? What do you want? Is there no such city? That means that you can't go anywhere. Yeah, whatever. It must be terribly slow though. Yes. That's how it is. Okay, we lost to Joffrey, but it's okay. I mean, I was terribly slow on that problem, and he was he skipped that problem because he was okay. I mean, we're faster than sellable. I consider it to be a success, to be honest. Okay. Let's quickly go through problems again. So in problem 1, we have to search in virtually complete binary tree. I didn't even read what it means to be a binary tree. I just seen that there are not too many nodes. So I wrote a DFS that generates all values and checked for list inclusion. I mean, it works in linear time in the number of nodes, so we are not terribly bad. I believe expected solution. Oh, we can work in height because we know actually where to go. So yes, of course, we know where to go based on binary representation of this number. Let's write actually adequate code. To Sorry, I got a little bit distracted by the music. Okay, so wait, I'm not sure. I'm not sure. There should be like a smart way to index, like big brain way to big brain way to traverse the tree. Let us find it. So powers of 2 go on the left, right? Actually, when if you are divisible by 2, then your last step is to the left. Okay, okay. So we can take binary representation of target, discard prefix. Actually, this is not the way to do it. Or is it? No, it's okay. So reverse generates it's a generator, so it's more a memory. No, it's not more memory efficient. Come on, we already generated this binary representation, so it doesn't matter. Okay. Let me also, I know it's not necessary, but I prefer to copy everything that I want to change inside the function. If bit no node get and node, let's go. No, okay, we should do it like this. If not node, return false. Otherwise, not has children. Or potentially it has like, or wait. No, it should be fine. It should be fine. Although here we obviously have else. I just quickly convert to Boolean. Let me think actually. No, I wrote something terribly wrong. I don't know what I wrote. Okay, let's face it. I just don't know how to solve problems in a smart way. I can just write DFS. It will append this value. It doesn't even care about the order. It will traverse left, traverse right, and by the end of the DFS, everything will be in vals values, and we can just return whether it's in or not. Here is the problem is that we can't make it like huge array. One huge Boolean array that sets bits off, on, turns everything off and on at once, and returns get value. The problem is, of course, we can't allocate that much memory without running into some issues, unless we are using std bit set. Actually. If they did not check against it, that's then I will be very displeased. Oh, we can't set everything to true with bit sets, right? Or can we? No. Is it? No, it's like this. I mean, if something works, then this should work, right? I bet there is a way. Oh, bad Alec. Bad Alec. I think it reverses like every bit. So if we first set to 0 and then to this, then yeah, but it's bad Alec because we used too much memory. So they are good, guys. So the idea how to solve it is to maintain like a global state, whether the array is completely, what was the last global operation on the array? And we also maintain a local operation that happens since the last global operation. So we just update local operations. When a global operation comes in, it clears all local operations after the global one. And get value just if it is in local operations and it happened after the last global operation, we can return it from a hash table. Otherwise, we return like global state. In case user to visit website, I use the following approach. So we sort. So first, we get like what starts and ends of each interval, and I see that says that the user can be case if its endpoint is after the start or after or equal to the start of k first users, and his starting point is begin or equal to the endpoint of case user, to the case endpoint. Because I believe that if these conditions are satisfied, then we can like and this user can insert, if this user gets like to the site on his last moment, then it is possible that he will be like case or further, right? Because if this condition does not hold, then no matter when he visits the site, there can't be more k users on the site. And we query exactly for k because we count himself as well, right? We count him. So at least one goes here and this one goes here, and that's why I did not need to check against k minus 1 and k plus 1. It's super nice. And here the idea is dynamic programming. We want to find out like what is the cheapest way to change prefix of our flight schedule. I don't actually know how to pronounce the word, this word. Let me check. Itinerary. How do they not pronounce like 2 R's here? I don't know. Whatever. So for every prefix of our road, okay, we want to find out what is the cheapest way to end up in every possible city. And that's exactly what we do. We need functions that compute the distance between strings so that we can like reuse it to find what is the cost of changing the current city to the one that we want to end up in. And because we have like not many edges, or I should say like a product of number of like our steps and edges is not huge, we can like for each current state check make dp transition over all possible edges that start at that point, and overall per layer you will get like no more than m transactions, and you have n layers, so you get an m transaction, and it's fast enough to pass. I honestly did not expect Python solution to pass because it's a pretty dumb way to do everything. Like, we are very inefficient. We like store every city. I believe there's no need to start cities from which you don't have like any further route, right? So you can cut the memory usage in two here. Yeah, so something like that. I don't know. Oh. Yeah, I believe I explained everything terribly. I just wrote all of this at it's a little bit too high pace, you know. I thought it all through during the contest, and now I can't find words that describe what happens better than and the ones that I already used. Oh, okay, what's our? Let's check the scoreboard. Okay, so a lot of people are just finished. We are second on the scoreboard. Congratulations to Geoffrey. We were the second person to finish the first problem. We were the first person to finish the second problem. We were the second person to finish third. Second person, I don't know. This seems like some cheat. Because honestly, like, you see a lot of people solve like this and did not solve this. Because it feels like it's not clear why these parts are independent, why you can check like that. And I believe like to fully understand, you have to look at the examples. Oh, but actually here people already like start solving good problems. Okay. Now it's not just like the problems are worth different points. So it's 3, 4, 5, 6. Or no. No, it's 3, 4, 4, 5, right? That's why it makes more sense to solve this actually like before. But so far we don't see like many people solving in reverse order, so maybe it's okay. Also, you see that here like 13 people solved, 23 solved. Yeah, 168 solved. So it's, and here like 289 solved. Cool, cool. Okay, so here we had a dynamic programming problem, which mysteriously passed because I believe they did not want to TLE whoever writes like correct, asymptotically correct solution. Yeah. So again, what we do is the following. We create a graph, which for some reason ended up being edges and not graph. Yeah, actually, this is like terrible. Let's. Right. I believe here we can do something like this. Then it makes much more sense. Right. I was just not thinking, like I typed edge and I wanted to change it to some different identifier, so I changed one letter and forgot about it. Prefix length, because it represents prefix. Like often semantically, some name is just much better than the other, and it's the case because you know. Actually, I have no idea why this is this kind of loop, because it's supposed to be this. Again, prefix length. Current city is for the purposes of this problem source, and it's redundant. No, it's not redundant. So, graph, okay. So this is the distance to source, okay? And out should be changed to destination. We are not getting any penalties, so it's fine to resubmit. Right. I'm not sure actually whether or not there is like built-in Python function that computes. Is there something like I don't think so. We have two strings, which are, by the way, unlabeled. Hello, typing. Actually, like there's no need to zip because we know that all distances are of length 3. Oh, it's an interesting problem. Like, what if characters are not like that? Yeah, you can change distance to like anything. And one interesting way to do it is to change to Levenstein distance. So I would definitely look for that one as well. First letter, second letter, first one. Yeah, let's actually break it up a little bit. So here we like have, we say like for every pair of different characters, we add 1 to the answer. Unfortunately, there's like no count function, so we have to do it this way. This is, the better representation is float infinite. Okay. This is pretty good solution. I mean, first version, I would implement like first version, but at the interview, if I have time, I would go back and like prettify my code. Yeah. Because it shows both of your Git qualities, right? You are able to both like quick solve problems. If you need some task to be done like for tomorrow, then you just write code. But you're also able to like make everything look pretty. Speaking of pretty, is typing imported? Typing is not important. Perfect. Actually, a better thing would be to have tuple of 2 strings. But it's unfortunately it's not the input format, because like I found it like they must use some like JSONs, and JSON does not exactly have tuples, right? It has lists. So that's why we don't have tuples in the input in Python. on binary search, tuples in C++, also we don't have them. Also on LeetCode, we don't have them. So we have tuples good. It's used in like practice, in development, real development. But it's like absolutely ignored on this kind of sites, unfortunately. It still looks awful, but it's the best that I can do. I mean, I can say like it's request index, right? But then it will be just very long. No, I actually think no. Okay, like this version is a little bit better than the previous one, but it's still pretty off. Let's actually go through example for this problem because I believe it's most like a non-trivial problem here. We have segments from 3 to 4, from 1 to 3, from 4 to 4. I'm not okay. What is sorted starting points? 1, 3, 4. What is sorted ending points? 3, 4, 4. Right? Then we are asked for the first element. So we go here and look at this column. It corresponds to k equals 1. What does it mean that k's starting point is 3? It means that if you end, your interval ends before this point, right? Then there is no way that k minus 1 user will start before you. So you will be like in top k minus 1 user. If this condition does not hold, you will be in first k minus 1 users. If this condition doesn't hold, you will be in last number of users minus k minus 1. But it's not obvious why, if both condition holds, then there's a way to achieve it. So for this, we need actually something like more provable, right? I just believe at the contest I implemented this because I believed I believed in this condition. After some mashups with indices, I got it right. So we have starting points, we have ending points. They are equal to some arrays. We have case element. Right? Now suppose that both these conditions hold. Then we can take these k minus 1 users, or actually we can take these k minus 1. There are k users. His endpoint is at most, his endpoint is, okay, like there are k users. He may or may not be one of them. If he's one of them, or even like this one, then we just say like everyone here comes before him. Then this part gets discarded automatically, right? So we are no longer interested in these guys. And we know that his starting time is before this and his finish time is after this. So we then again say like everyone who's here he may or may not be one of these guys. And we can always select like n minus k minus 1 user here. And we know he is before this, but endpoint is after this. So we can insert him perfectly if we say that this user comes at the start and this user comes at the end of their time. So that's why we can insert if this condition holds. Yeah, it was not trivial because like you may think like what happens if he is one of them? And the answer is like he needs to be case. So we need only k minus 1 in front of them. And because we checked like for k and his time is most probably among these times, so that means that he can be there. Because if his time is among this, yeah, his endpoint is after this. So his start time may be among this, but then we'll have k minus 1 left over, and it's enough. And the same goes for this. And these are independent because we always select like out of this and out of this. Right. Okay. So that was it for today. I don't know, like if you think it's cool, it's cool. I think we did almost everything that we could. I was a bit slow on the implementation part here. Like we can see that Geoffrey implemented this problem in 6 minutes and I spent 11. On the other hand, like he spent 10 minutes here and I spent like 8 minutes here. So sometimes we win, sometimes we lose. It happens. Okay, it's obviously better than previous times, right? Sorry, I got distracted by music again. I think this is it for today. I will try. I think like I will publish my editorials if they have any use after others publish their editorials. And basically, see you tomorrow with some philosophy video. I have like really cool, interesting ideas, like not about any technique or algorithm in general, but about like how you should approach competitive programming in general. I believe I don't have like all that much experience, but some of my observations about like the things that I did wrong in my preparation, I think this helped me become a bit better recently. So yeah, that's it for today. Thanks for watching. What can I say? What can I say? It was really exhausting. So tomorrow we don't have any contests, and I don't. Yeah, and even if we were to have any contests, then I would not participate because currently I'm exhausted. Thanks for watching. See you tomorrow, and for today, bye bye.